All right. Hi, everyone. Thank you so much for joining our June webinar. We are going to be talking all about turbocharging translation quality with the power of custom engine training. Before we get started, I wanted to cover a couple of housekeeping items. So the first is please put any questions that you have into the questions tab, and we will hopefully have a couple of minutes at the end to answer those. Also, we will be recording the entire session. So if you need to step away for any reason or want to revisit any of the content later, you can catch up on that. And we will share that later today or early tomorrow. So let's get into it. I am joined by two excellent speakers today. The first is Olga Beregovaya, the VP of AI at Smartling, and Alex Yanishevsky, who is Smartling's Senior Director of AI Solutions. So welcome, Olga and Alex. Thanks so much for joining us.
Thank you. Thank you, Cassie.
Thank you.
All right, I'm going to go ahead and pop our slides up here for us. So let's start off with why companies are still actually investing in custom machine translation engines during the age of AI. Why not just use AI? So Olga, do you want to talk a little bit about that?
Yeah, I mean, first, maybe I want to clarify that machine translation, neural machine translation is equally AI. Right. So maybe we should talk about machine translation and Gen AI, generative AI, and why not just limit it to using generative AI for all translation tasks. And as we see now, we at Smartling do a lot of benchmarking. And we don't just rest on the laurels, we actually do benchmarking regularly, Alex and team. And we still see that with custom engines, we still outperform, with custom engines, we actually outperform generative AI, outperform large language models. What's more, even with our auto select approach with generic engines, we also still beat, like here we're looking at GPT-4, now GPT 4.0, we still see that we get higher blue and we get lower edit distance, and that's what we want. So we have tangible proof that yes, despite all the merits of different tasks that large language models can perform, we still see that translation performance is still superior. And then Alex will later talk about trained engines, and we'll see that the trained engines follow the upward trajectory. So these are the machine translation or automated translation scenarios that we stand by and promote here at Smartling. So if you want good translation, you can actually use our auto select technology, and that would be selecting the best generic, non-customized machine translation engine for a specific language pair. And we actually run a machine learning model behind the scenes that actually is trained on our platform performance data and consistently is updated and recalibrated. So you know that based on the state of the art and based on the state of the engines at that particular point in time, you actually get the best engine. Then you go with a better, where you actually customize an engine with your linguistic assets, such as do not translate lists, brand book, translation memories, and glossaries. And we hear a lot of industry conversations, and we definitely back them, that translation memories, while serving the content reuse and leverage purpose, are becoming more and more of model fine-tuning and engine training corpora. And then basically the last one, the best scenario, and again, we'll talk about that later, is you do have your custom machine translation engine. So you've already captured quite a bit of your brand preferences. But then if you combine it with self-learning dynamic AI features, that's where you actually get the best results. And the features would be dynamic fuzzy match repair or dynamic leverage adaptation, AI enhanced glossary insertion, formality switching, and going forward, other smoothing techniques. So this way, you actually have a translation solution for literally every case if you use the approach that fits you best. And we will still say that AI-powered machine translation is best or pretty much guaranteed delivery, quality delivery for support tickets, forums, reviews, knowledge-based training materials, product information, time-sensitive materials with short shelf life, subtitling. But interestingly, we see more and more content graduating from the second category, AI with human post editing, graduating to AI-powered machine translation category. You probably still want human eyes, depending on the sensitivity of your content, on patents, product manuals, especially, I mean, most definitely in the life sciences and regulated industries, blogs, commercial contracts. But again, quite often it's fuzzy territory between AI powered translation and AI with human post editing. And then you still have specialized translation, which would be high touch marketing, more need for more additional QA and specialized translations. Again, we can use life sciences as a great example where you could still want full human translation. So that's the landscape. And again, trained engines play a significant role everywhere, except for if you decide to do human translation from scratch.
Awesome. Thank you so much, Olga. That was super informative. And thank you also for clarifying too, generative AI versus just AI, and it's kind of its own playground there. So you talked a little bit about the metrics at the beginning, but how do we actually know that trained engines are better than, let's say, normal neural machine translation?
Uh, there are definitely, I mean, there are ways of measuring the quality of any automated translation, be it machine translation or be it translation using a language model, be it large or small. There are two ways, right? There are automated metrics and then there is human evaluation. So let's pause for a second. Obviously, automated metric is machine time, short press of a button. So the metric bleu, and later we'll look at edit rate, the two automated metrics that I used most. And blue is the higher, the better, stands for bilingual evaluation understudy. That's probably one of the oldest, next to NIST, maybe no, it's still younger than NIST, one of the oldest metrics to evaluate the quality of translation automation. And the second one would be edit rate, which is basically you want your translation as close to human translation as possible. So you want your edit rate the lowest. And these are the two metrics. If you put them side by side, you can actually easily and quickly evaluate the quality of your automated translation. They're both referential metrics, so you do need human translation to compare to. Yeah. And again, if we look at trained and generic engines, you still see the same trend. You still see here we're comparing baseline Google model and Google AutoML model. And you can still see that there is significant lift in performance, 22%. But when Alex and team are working on engine training, we've actually seen up to 100% for under-resourced languages where the client has a lot of training data. But on average, you get 22% fewer edits. So you see that once you've customized the engine, and then we'll talk about some additional techniques. But that for the intents and purposes of this conversation, once you've customized the engine, you definitely see a significant uplift in quality. And that's what we want.
All right. Thank you so much, Olga. That's super helpful. Alex, any comment you want to share on this metrics before we jump into the next piece on how we train engines?
Yeah, as Olga said, right, just to reiterate that, you saw in the previous slide a decrease in edit rates, right? So that means when a human is in the loop, right, there's a linguist involved, they're editing less, so they're far more productive. And on the next slide, we're showing blue where there is no, as Olga said, there is no human in the loop, right? We have a reference translation, and the higher this number is, the more actionable. So we see on the whole a very significant increase in the trained engines. And that's important because when there's no human in the loop, you have only one opportunity to get it right.
Great. Thank you for that clarification. So Alex, you and your team are responsible for all the deployments of custom trained models at Smartling. So you're definitely an expert in this area. Can you talk a little bit about what exactly happens once you start training an engine?
Yeah. So I wanted to kind of go a little bit under the hood and kind of explain what is it that happens, right? So you do have the ability to train an engine by basically taking this, upload and pray approach, which basically means you take your linguistic assets, you upload them, and you kind of start praying and hoping things work out. As you'll see in the following slides, we don't do that. We go to great lengths to actually curate the data and select the data that's most relevant, right? And the reason for that is you can actually see that in the screenshot, right? The idea is, right, garbage in, garbage out, right? An engine, you're not going to be able to make a model better than the data that it starts out with, right? So if you have poor data, you're going to have a poor model. So it's really, really important to find any noisy data, any inefficient data, less than optimal data, and actually either fix it or get rid of it, right? And we'll talk about some techniques that we have a bit later for fixing things. But at this stage, right, what we're doing is we want to curate the data, find data that's noisy, that's unreliable, demarcate it as such, and get rid of it, right? We also want to fix incorrect data to the degree that we can and do it in a reliable manner. And finally, we want to select data that's going to be unique and that's going to be representative of production, right? And finally, as Olga said, we showed a couple of scoring metrics. We actually run 8 different scoring metrics, and think of the globe that we spin in different ways to make sure that when we give the green light and we put an engine in production, we've looked at all possibilities to make sure that it's acceptable within the historical thresholds.
Apologies, Alex. I wanted to quickly correct myself, and the slides are fairly tiny in the presenter view. I actually got the metric wrong when I was commenting on blue. Actually, we had TER on screen, so I wanted to correct myself. Back to you, Alex.
Yeah, so let's take a look at some of the tasks that actually happen behind the scenes, right? So the first thing we do, as I said, is we curate the data and we select the data. So we have tools that will identify inconsistencies in the translation memories, and even more importantly, between translation memories and glossary files, right? So we can find things that are unreliable, and in some cases, for some categories, we can actually correct them. And that's extremely, extremely important because we're trying to automate as much as possible because it's so expensive to have human beings involved. Then we do the same thing with a glossary, right? There are glossaries that are fit for a human linguist to edit, but a machine translation engine, right, the learning algorithm, will want something that's very clear and unambiguous. So we actually make sure that we get rid of ambiguous entries, right? Then we go ahead and clean TMX files, these translation memory files, in a way that the machine learning algorithm expects them. So for example, some models like Google actually say that they prefer not to have tags, right? So there's a set of heuristics that we do to get rid of tags, yet still keep placeholders and variable in place so the engine learns that there will be things in there during production. Lastly, we split this translation memory into 3 buckets, into a training set that's primarily what the engine learns on, tune set that helps to tune the parameters, and a test set, which is what we're testing on, how we're doing our automatic scoring. I won't go into great lengths, but essentially the reason we're doing this is because in the upload and price scenario, sure, you could throw in your translation memory files, but you actually don't know what's happening. The whole point of this is to show that we have lots of control so we can actually see what's happening with every single segment that the model gets trained on. Yeah, so if you go in this slide, right, one of the things that we want to show is, again, this scrupulousness, this granularity with which we look after the task. So what you see here are actually it's basically a summary of all of the inconsistencies for different error categories, right? And some of them, we put a different priority of them, and some of them that can be fixed, we can go ahead and fix automatically, right? Those that can't be fixed, we can have a linguist review them if we can't self-heal them, right? So this is a good way for us to basically look and see historically, even before we start training the engines, how clean is this data? Do we expect to have problems or not, right? And that actually allows us to go to the next stage, which is to train the engines themselves, right? This is an example of what happens, again, the sort of granularity that we look at glossaries, where we look at every single entry and we make sure that it's the correct part of speech and that there aren't inconsistencies between what you have in the source and what you have in the target. And then, so this last slide, this is something that allows us to actually, this gets into the question of engine maintenance, which is going to be our next topic, which is how do we make sure that once we train an engine, that that engine is fit for purpose? And as your model, as your content begins to develop, right, and your technical writers, your authors write more, how do we make sure that the engine stays fresh, right? So what you're seeing here is the ability, number one, to look at not only scoring, but to look at the nature of the scoring. So in other words, what tangibly did a human being do? Did they change a punctuation, in which case it's stylistic preference, or did they actually change a very significant word, right? And the other part, it also allows us, as the engines change, what you see in that other screenshot with a bunch of dots, we can actually plot every single sentence that exists and see if what we're getting in production matches what the engine was trained on, right? So that's a way for us to make sure, again, in a very automated fashion, that if we trained, let's say, on online documentation and we're getting legal, we can immediately say, hey, wait a second, we need to retrain the engine.
Awesome. Thank you. And yes, you definitely did set up our next topic here, which is about maintenance. So obviously there's a lot of detail that goes into curating the training materials for these trained engines. But once a custom model is trained, is it a set and forget situation, or is there some sort of ongoing maintenance that needs to happen?
So definitely there needs to be ongoing maintenance that needs to happen. That's kind of what I was trying to get at in the last slide with this content drift that we can map. Personally, I like to think about it, much as I know that most of us, for example, dread going to the dentist or going for an annual physical, right? Think of your engines the same way, right? If you don't go to a dentist for a couple of years, chances are when you go, you'll have cavities. Machine translation engines are the same way. Your content is going to continue to evolve because you're a dynamic organization, right? You're going to create more features, you're going to sell your software. But if the engine stays at one point, right, it's not going to be able to accommodate that. That's why it's very, very important on a regular cadence of 6 to 12 months to retrain engines and prevent content drift. Right. And we also want to make sure that the glossary is up to date. So again, we're always adhering to the corporate brand.
Great. Thank you. Olga, anything you wanted to add here?
Yeah, I actually wanted to add about the glossaries, keeping the glossaries up to date. While it's absolutely good hygiene to retrain your engines regularly, there are quite a lot of times your brand got only updated for a couple of terms. So later we'll talk about ways that you can actually update your engine just by updating the glossary only and using dynamic features outside of the engine. So you can actually combine engine training with just maintaining your terminology if the changes are minor.
Great. I'm going to stick with you, Olga. So you mentioned earlier that the best case scenario is to use LLMs and custom engine training together. Could you talk about how companies are doing that?
Yeah, absolutely. So basically, as we say, LLM is used for the last mile. So we do know that neural machine translation in the modern time and day, as we know it, is already very powerful, right? And we see high MQM scores and we see high automated metrics. But where machine translation, just based on the way it's designed, machine translation transformer models fall short is you still lose quite often grammatical fluency, right? And there are still nuances like formality. And there's quite a lot of conversation about how automated translation can actually help us drive diversity and inclusivity. So there are a lot of things, and also adherence to stylistic preferences, or actually the persona that you're selling to. So, or you're marketing your products to. So there is a lot of room for actually using large language models in this scenario. Now, we obviously hear there are a lot of conversations, and we hear quite often, hey guys, why not just plug in large language model like say GPT and just call it a day and use large language models as machine translation providers? And the reality being, again, doing diligent benchmarking, and you can see the benchmarking data here to the right, we still see that large language models as we know them do not outperform machine translation. They don't show superior quality. And then it's been mitigated all the time, the notion of latency, but you still see more latency with large language models quite often than with more established neural machine translation technology. So all these factors combined, you can actually tweak the output of your machine translation with further automated post-editing and things that you need to consider if you choose to use large language model for translation. They actually make us promote the ensemble approach, and that's where we see the best results. Now, here at Smartling, if you guys have been following our news, we recently released something referenced as AI Translation Toolkit. And earlier we spoke about getting the best output if you've customized your machine translation engine, so you've already established brand relevant baseline. you already took care of that, right, on the engine level. But there are a lot of dynamic features that you can actually have in the platform that go a step above the engine level and happen dynamically. So AI-powered translation memory, where we actually use large language models to bring the fuzzy match closer to the updated source. So automatically, we actually see uplift in about 35% on average in your fuzzy match leverages when we use this technology. Then you run your machine translation. We already went through different machine translation scenarios, and we see the best performance with a custom engine. Then something that I just referenced, which is APE, automated post-editing using large language models and other natural language processing methodologies, like, for instance, Roberta, trained instance of BERT. So this is where you take care of formality. This is where you take care of smoothing. And this is where you take care of other nuances that you want to plug in. And then there is something else that's very interesting. Okay, you've done your automated translation. What do you want to do from here? Does the human really need to see everything and pay the same attention to everything? And the answer is no, not necessarily. Actually, once you've delivered the highest quality possible automated translation, from there, the next logical step is, hey, let's not even look at something that machine already confirms, quality estimation already confirms that doesn't require human touch. So all these pieces combined, that's how you can actually get the best possible translation to the market. And again, trained engines still play a pivotal role here. I don't know, Alex, if you want to add anything to this.
No, I completely agree about that. We haven't seen LLMs outperform fine-tuned models yet, even if we're using some methodology with retrieval augmented generation. We're not there yet. I think that's why this ensemble approach that you described, I think that's the most efficient and the best performing that we've seen thus far.
Great. All right. Well, I'm going to just have our talking heads for the end of this. You just mentioned something, Alex, that I wanted to follow up on. I know there's been a lot of talk in the industry about retrieval augmented generation, or RAG, you may have heard, and also fine-tuned models. So can you talk a little bit, Alex, about where that fits into the equation of trained engines?
Yeah, so this is kind of continuing the thought that Olga had on the previous slide, and what I was beginning to say. So we see that RAG is very efficient, retrieval augmented generation, and we're using it, but we're using it in an ensemble approach. The reason for that is, again, we haven't seen RAG outperform fine-tuned models, and basically our position is that rather than concentrating on the engine being dynamic, let's make our entire process dynamic. So the way we're using RAG, and Olga was showing examples of this with very dynamic AI fuzzy match repair with glossary term insertion. We're going to be introducing formality as well, right? It gives us the ability to use multiple translation engines, but smooth out any inaccuracies by using RAG and using LLMs on top of that. I don't know, Olga, if you want to add to that, right? So the idea is we're not constrained to one, and we're focusing on the whole process being dynamic.
Yeah, no, I don't have anything to add. I agree completely.
Great. All right. Last topic before we move into Q&A is really about, ROI and how to choose when to use a custom engine or not. So obviously custom engines sound great. The performance is already proven to outperform any other type of machine translation, but it takes time and money to implement them. So what are some considerations for people out there who might be considering whether to train an engine or not? Olga, do you want to kick us off with that?
Yeah, I'll kick us off gladly. So it's always about the ROI, right? And it's always about, so, hey, I've invested into a custom engine. What do I get for this? And generally, it's a reasonably simple matrix. If your translation memory is super high performing, and if you've accumulated clean translation memory, and again, here at Smartling, we pay a lot of attention to helping our customers maintain their linguistic assets up to par with their current state of the process. So if your TM fire is really high and you're super high, like the delta that actually will go into machine translation of new words and lower fuzzy matches is tiny, it might not be worthwhile for you. you can actually benefit more from other dynamic features around. But if you see that the content that will go to machine translation below a certain threshold is significant, and the content and your translation memories actually will deliver a lot of value, but still don't fully cover like the high leverage, the high fuzzy matches and exact matches, then we definitely will say go and train. The other, I mentioned the other case where sometimes we see 100% increase in quality. 80% is if generic engines just do not have the sufficient coverage for your vocabulary. Alex would remember the case, Alex, right, where it was traditional Chinese. It was very specialized domain. And when Alex showed me the scores, I was like, no, you got to be kidding. It cannot be, because the scores were extremely high compared to baseline. And the reality was that traditional Chinese engines just did not have, the generic engines just did not have the sufficient coverage for this particular domain. So ROI, quality of your translation memories, and what coverage can you actually get from a generic engine.
Alex, do you want to add anything else that you've seen as sort of the decision maker on whether to invest in this area?
No, I mean, I think Olga covered it very well. I think ROI really is the main question there. You know, what's the analogy that I like to use is you can get to work in a stable car and you can get to work in a really, really fancy car, right? And it's a matter of finding out what's the best value for you.
Great. Well, thank you. Oh, sorry. Go ahead, Olga.
And maybe the other thing that we had a discussion, Alex, earlier about RAG can actually be more expensive depending on actually how much you pull into your prompt. There is also the consideration. You can actually put the custom engine side by side, right? And you can see which approach actually gives you equal quality and performance. The other consideration, actually, we're working very closely with Google, and we're very pleased with what we see with Google Adaptive, which is basically a large language model created specifically for translation automation. So there is always a way of, if you don't have sufficient, or not sufficient, but say standard 10,000 translation units, you can actually fine-tune Google Adaptive engines with significantly lower number of words or translation units and still get very good results. So we actually just presented at Google Next conference, and that's another approach where you do customize, but you actually customize with much lower volume of training data.
Great. Well, thank you so much, both. We do have a couple of questions that the audience has submitted, so I'll pose those to you in a minute. But any last kind of words on custom trained engines before we get into Q&A?
I think I'll just go with, for all we see, they're here to stay. Obviously, we'll see much more convergence of large language models, Gen AI, and machine translation. As I just said, Google Adaptive is a great example. But in the modern time and date and in the foreseeable future, engine trainings combined with LLM features gives you a significant uplift in quality.
Alex, any final comments before we jump into Q&A from you?
No. I guess let's jump into Q&A to make sure. I mean, it looks like there are people who are asking really, really good questions to make sure that we cover them.
Let's do it. All right. So if you have any questions, feel free to also put them in the Q&A. We'll still take those. One quick question on what Olga just shared. Translation units, does that mean strings, or how do you quantify the data needed to train an engine?
Yeah, actually, I'm using the good old localization industry vernacular. In this case, translation unit is the unit of thought, right, in TMX, in the TMX format, which is the format we store translation memories in. So depending on your segmentation, we can call it a string if you wish, but depending on your segmentation, that can be a sentence, that can be a paragraph, really depending on how you segment your TU. But as you train, I mean, you and Alex, you touched on it, how we curate, we would filter out like strings that are too long. But I would say, yeah, the easiest way to think about it, you can equate it to a string and quite often to a sentence. I know, Alex, if you want to add to this.
No, that's I mean, I would regard them synonymously as translation units equal strings, and then there's a lot of work that we do when we actually begin to curate data to look for strings that are unbalanced, and see if we can fix them, and if not, then we discard them and basically form form enough of a string that we could give the machine learning algorithm the opportunity to put its best foot forward, right? Essentially, you don't want a string of more than 50 words because then you see a degradation in quality.
Great. We got a really great question from Marcus. How does using trained engines and MT change the way we create master or source content?
I would probably want to take this one. Okay, the engines will not ask any questions or demand clarifications on the content that we are providing. Yes and no. And there is a whole, again, it's, if you think about, like, for instance, Acrolinks, right? The first authoring platform that actually took into consideration authoring for translation and authoring for machine translation. I would say that there are quite a few considerations into how you actually create your source to make it most translatable. And there are a lot of techniques you can actually apply for pre-editing your source for machine translation. So, or machine translation, or in general, automated translation. You can actually go in and you can pre-edit your source and make it more translatable, and then make a decision what version of the source you want to reuse. So I would say that it's still source content profiling and source content assessment. Source plays very, very significant role in machine translation driven process. And there are a lot of things that, again, we've run webinars on writing for automated translation. There are a lot of things you want to avoid. There are things like you want to avoid subjunctives. There are things that you want to reduce passive voice. Obviously, you don't want too many abbreviations unless they are brand abbreviations. You don't want noise. So there are a lot of things you need to consider that human translator could deal better with than automated translation. If you don't do any of those things to your source, you'll still get good quality translation. It's just not going to be as good and as solid as if you considered those pre-editing techniques for your source. Alex, you want to add to this?
Yeah, I guess the only other thing, I completely agree with you. Only other thing I would add is we also have the ability to kind of work backwards and do a certain amount of reverse engineering, right? We can look at the edit rate and the productivity of the linguist on a project after they finished, and if it's anomalously high, we can actually do we can look at the source and see if it's the complexity in the source that led to this inefficiency in the first place, right? As Olga said, we're still going to translate, we're still going to get it up to a high MQL level, but can we do something in the future to reduce this extra stress on the linguist, right? And that's what source content optimization and profiling allows us to do.
Great. Peter asked a great question as well around glossaries. So does Smartling automatically pull in the most current version of the glossary into the MT workflow? And how does that work with trained engines?
Olga, I can take this one.
Yeah, short answer, yes, it does it automatically. Long answer, what happens in the back end is when you update the glossary, right, as part of the AI translation toolkit that Olga was showing, when we form the machine translation, right, even with a trained engine, we do a check to see if the glossary has been adhered to. If for some reason it hasn't, then what we're doing is we're doing a RAG to the active glossary, right, that sits as one of the linguistic assets, pulling that out as an example in the prompt to the LLM and correcting the MT that way, right? So all of this is happening automatically.
Alex, do you want to touch on, since you're on the topic, on optimized glossaries, and maybe clarify a little bit what we mean when we say MT optimized glossary? Because it's still current, but it has certain tweaks to it.
Yeah, so one of the things that we introduced in the platform is the idea of glossaries that are specifically optimized for machine translation. And I kind of began to hint at that in kind of earlier slides, and converting to an MT friendly format, right? So what I mean by that is it's not uncommon in a glossary that's meant for a human being to have, for example, verbs by themselves, to have ambiguity, to have linguistic variations, right? To say this translation, comma, this translation, or semicolon, this translation, because a human being will know as they're reading it what's meant in this context. A machine translation engine won't, right? An LLM necessarily won't. So one of the most important ideas of optimizing for MT is that we get rid of those ambiguities, right? A machine doesn't work well with ambiguities. So we identify those ambiguities, we discard them, to make the glossary optimized specifically for using machine translation, right? But then the nice thing is you still have the regular glossary available for a linguist as they're doing their editing.
Great. Thank you. All right, we'll ask one last question before we run out of time here. And it's really more of a sort of a tactical question. How do I prepare my translation memory to be used in custom engine training? How big does it have to be? You know, what are the considerations? How could someone get started if they were interested in this?
Can I, maybe I can take this one. I think our short answer is going to be just let us do it for you. That would probably be our approach. Again, to Alex's point, there is always upload and pray, right? Where you would just use the native engine native training interface. But there are quite a lot of techniques that we've developed over the years on, and Alex alluded to most of them, on preparing, taking your translation memory and converting it into engine training by text bilingual corpus. So we would just say, just engage your partner, your translation partner, and let us do it for you. There are a lot of things. I mean, you obviously can reverse engineer it, but there is a lot of deduplication, disambiguation, filtering out longer strings. There's quite a bit of IP, for instance, on our end that goes into it. The only rule of thumb we would say, you want to land at no fewer than 10,000 translation units. That's the only, again, unless you're piloting and trying out the likes of Google Adaptive, 10,000 translation units is where the weight of trained models actually becomes significant. So if you have 10,000, off we go. If you don't have anything to start with, we can start with a glossary and then build up the training data for you as we go.
Awesome. Well, thank you both so much. I really appreciate your time and insights, and I'm sure all of the people who were here today also appreciate that. So our next webinar will be in July, and it will be all about managing compliance with language regulations for governments and school districts. So if you're in that space, definitely join us for that. And thank you so much for your time. We hope you guys have a great day. Thank you.
Thank you for having us.